So homework day 20, starting chapter 3, wants you to classify a system of linear equations from graphs. A system of equations just means you have more than one equation. We're going to just work with two equations. It says for each system of linear equations shown below, classify the system as consistent dependent, consistent independent, or inconsistent, then answer the question about its solutions. So what it's trying to get across is that when you draw two lines, there are three ways you could draw two lines. The most common way if you draw two lines is that they're going to intersect in a point. If my two lines intersect in a point, they're called consistent independent. Independent kind of means that there's one thing, you're standalone. Consistent independent means you're going to get one solution because they intersect in one point. The other common way, or another common way of drawing two lines, is if I have two lines that are exactly parallel to each other. If they're parallel to each other, they're not going to intersect, and therefore they're not going to have a solution that's common to both of them. And so those ones are called inconsistent. And they're going to have no solution. And the third way to draw two lines is actually having one line right on top of the other line. If I could draw straight. Every single point is going to work in both equations because they're really both the exact same line. Those ones are called consistent dependent. Consistent because they have answers, dependent because it depends on the equation, but those are going to have infinite many solutions because there's an infinite number of points on the line, and any point that works in one line is going to work in the other line. So on these ones, they're always going to give you three examples, one of each of those three things, and you're going to pick what kind of equation it is and how many solutions you have. If it's one solution, you have to write down what the solution is. So looking at this first one, we can say line 1 is y equals negative 1/2 minus 1. Line 2, y equals negative 1/2 x minus 2. My slopes are the same, therefore my lines are parallel. And if my lines are parallel, they're going to be inconsistent and have no solution because those two lines are never going to intersect each other. The second one there's one where they intersect in the point. If they intersect in one point, they are consistent independent. Independent, one point. The point that they cross at is the solution. So you're going to have a unique solution, and then they're going to have you put the ordered pair in there. This crosses at 1, 3. And so 1, 3 is a point that would work in both of my equations if I substituted it in line 1 and line 2. And then the third way is when they look like you have two different equations, y equals negative 3x minus 3, and then 3x plus y equals negative 3. But when you graph them, they actually end up being one line right on top of the other line. Those ones are called consistent dependent, and they're going to have an infinite number of solutions, infinite many solutions, since every point on line 1 is going to work in line 2. So number 2, same thing, picking out what kind of system we have and how many solutions. So the first one there, that system is which kind? Consistent, independent, because they have one solution, and its unique solution is what point? 0, 3. 0 over up 3 where it touches the graph. The second one on number 2 is which kind? It's inconsistent and has
solution.
No solution, because my lines aren't going to touch each other. So they have nothing in common. And the third one looks like one line, but it's actually one line on top. The other one is which kind? Consistent dependent, and has
Infinite solution.
infinite many solutions, because any point on line 1 is also going to work on line 2. And 3 more of those. Number 3 there. The first one is which kind?
Consistent independent.
Consistent independent, and has
A unique solution.
a unique solution at
3, -1.
3, -1. Across there at 3, -1. The second part of number 3 is which kind?
Consistent dependent.
Consistent dependent, and has
Infinite many solutions.
infinite many solutions, because every point on line 1 also is on line 2. And then the last one on number 3 is inconsistent, and has
No solutions.
no solution, because they're not going to touch each other. So that's just picking out what kind of equation you have, or system of equation you have. Then we're going to get into solving some systems of equations. There's really a whole ton of ways to solve systems of equations. In intermediate algebra, we're just going to do 2 of the ways. If you take college algebra, we'll do more than 2 ways. So, first way, solving by substitution. If one of the equation is already solved for x or y, or is easily solved for x or y, then substitution is a good method to use. If y is equal to 3x minus 4, we're going to substitute that into the second equation in place of the y. So rewriting the second equation, we're going to have 4x plus 3, and in place of the y, we're going to put the 3x minus 4. That's going to equal 27. We then solve that like we solved all those other equations before this, getting rid of our parentheses. 4x, 3 times 3x would give me plus 9x. 3 times minus 4 would be minus 12, equals 27. Combining my like terms, 4x plus 9x would give me 13x minus 12 equals 27. We then have to move the 12 to the other side, so we're going to add our 12. 13x equals 39. And of course the last step is dividing by our coefficient of 13, so x is equal to 3. If you're not getting a nice whole number answer, go back and check your work. I believe all these ones come out to nice whole number answers, or at least integer answers, because they might be negative. Once I found x, I'm going to go back up here to my first equation and find y. Y is equal to 3 times the x value, which was also 3, minus 4. So 3 times 3 is 9. 9 minus 4 is 5. If I wanted to double check my equation, I would check it in the bottom equation, putting in the 3 for x and the 5 for y. So 4 times 3 plus 3 times 5, does that equal 27? Well, 4 times 3 is 12, 3 times 5 is 15, and sure enough, 12 plus 15 is 27, so I know, yep, I did it right. And all my scribbling, there's my 2 answers. So, solving by substitution. Number 5, then, we're going to use substitution to solve it. This time, the bottom equation, the x is equal to 3y minus 18. So we're going to substitute in for x in my top equation. What should I have when I substitute in for x? Five and then parentheses. 3y minus 18 plus plus 4y equals 5. So we just replace the x here with the 3y minus 18 from the second equation. So using our distributive property, we're going to get what? 15y minus 90 plus 4y equals 5. Combining our like terms, 15y plus 4y. 19y minus 90 equals 5. Then we're going to add the 90. 19y equals 95. And our last step, dividing. 95 divided by 19. 5 times. Good thing it came out to a nice whole number because that's a good sign. So we got y equals 5. We still need to figure out what x is. How are we going to find x?
Using the other equation.
Using our other equation that says x equals 3 times the y value minus 18. So 3 times 5 minus 18 gives me 15 minus 18, which is negative 3. So x would be negative 3, y would be 5. So number 6, we're using substitution to solve the system of equations. We need to have one of our equations either solve for x or y, and neither of them are. But if I look at the top equation, I can easily enough solve that for y by moving the x term to the other side. So y is going to equal, I have negative 5, and when this comes over here, we have to add our 3x. So y is going to equal negative 5 plus 3x, or you could write 3x minus 5. Either way should work. We are then going to solve by substitution. So we're going to plug this in for the y on our bottom equation. So rewriting our bottom equation, it starts off with 2x minus 5 times that y value, but in place of the y, we're going to write negative 5 plus 3x equals 12. In order to solve that, we're going to get rid of our parentheses. So using my distributive property, 2x, negative times a negative is a positive 25. Negative times a positive would be minus 15x equals our 12. So if I combine my like terms, 2x minus 15x would be negative 13x plus 25 equals my 12. Solving that, I am going to subtract my 25. So negative 13x is going to equal 12 minus 25 would be negative 13. Then, of course, my last step, just dividing by my coefficient of negative 13. Negative divided by negative gives me a positive, and 13 divided by 13 is 1. So x is going to equal 1. When I go back and I want to find my y, I could really substitute it into any of these 3 equations, but because I've already rearranged that first one and solved it for y, it's easier to put it in where it has the y equals. Y equals negative 5 plus 3 times the x value, and in for the x value we can put 1. So negative 5 plus 3 gives me negative 2, so y would equal negative 2. Checking that out, 2 times 1 minus 5 times negative 2, does that equal 12? 2 plus 10, sure enough, is 12. So yep, it checks out. X is equal to 1 and y is equal to negative 2. Number 7, we are going to solve systems of equation using the elimination method with multiplication and addition. if I would try to solve either of these equations for x or for y, I'd have some pretty nasty looking fractions, and most of the time we don't like fractions, and so we have to find a different way to solve that. One of the ways to solve it is by what they call the elimination method. We want to either eliminate the x's or eliminate the y's by finding a common multiple and then multiplying either one or both of our equations so we have opposites. So in this case, if I want to get rid of my x's, I want to think about the least common multiple of 3 and 4. The least common multiple of 3 and 4 is 12. So I want one to be positive 12 and one to be negative 12. Since these already have opposite signs, I don't have to worry about making the signs opposite. I just need to make the numbers 12. So I'm going to take the top times 3 and the bottom times 4. 3 times negative 4 would give me negative 12x. 4 times 3x gives me positive 12x. When I do that, I have to multiply it by the entire equation. So I'm going to multiply the whole top equation times 3. 3 times negative 4x is negative 12x. 3 times a positive 9y is a positive 27y. 3 times 19 must be about 57. My bottom equation, I'm going to take everything times 4. 4 times 3x is 12x. 4 times negative 4y is negative 16y. 4 times a negative 17, negative 68. Now I'm going to get rid of the x's by adding those two expressions together. Negative 12 plus 12 would give me 0 x's, or get rid of the x's. 27 minus 16 would be 11y. 57 minus 68 is negative 11. And then all I have to do to solve that is just divide by my coefficient. So negative 11 divided by a positive 11 is going to give me negative 1. Now in this one, it's not quite so easy to find my other answer. I have to substitute that negative 1 in either of my two equations and then solve it for the missing variable. So in this case, I'm just going to pick the top equation. If I do the top equation, I'm going to have negative 4x plus 9 times my y value. We had y was negative 1 equals 19. So when I solve that, first thing I want to do is get rid of these parentheses here. So negative 4x, positive times the negative would be negative 9 equals 19. Solving that, I'm going to have to add my 9. So negative 4x is going to equal 28. And dividing by my negative 4, x is going to equal negative 7. So negative 7 and negative 1. Same kind of thing, if you wanted to check your answer to make sure you did it right, substitute in for the x and the y on your opposite equation. So take 3 times negative 7 minus 4 times negative 1 to see if you get an answer of negative 17. Negative 21 plus 4, sure enough, is negative 17, so it does check out that x is negative 7 and y is negative 1. So on that top equation here, if I want to get rid of the y's, because I have this as 6, we said we want to multiply that top equation times negative 2. I didn't take the 1 times negative 2, so it didn't come out right. Negative 2 times 4x was negative 8x. Negative 2 times 3 would have been minus 6y. Negative 2 times 1 should have been negative 2 instead of 1 there. The bottom equation is going to stay the same because we had that plus 6y. 7x plus 6y equals 7. So when we added those together, negative 8 plus 7 would have been negative 1x. Our y's would have canceled. Negative 2 plus 7 would have been 5 there. Dividing by negative 1, x is going to equal negative 5. Then we still have to go back and find our y. We would put the negative 5 in for the, or in for the x value on our top equation. So 4 times the x value of -5 plus 3y equals 1. 4 times -5 is -20 plus 3y equals 1. Adding my 20, 3y would have equaled 21, and dividing by 3, y equals 7. So you'll want to fix number 8 there because the answers there should have been -5 and +7. Number 9, if I have -4x plus 7y equals 4 and 5x minus 6y equals -5. I don't know that either the x's or y's would be too much different to solve. I'd probably just use the x's because my numbers are smaller. If I want to eliminate my x's, what should I take the top equation times?
5.
5. And the bottom equation times? 4. Because my least common multiple would be 20, and I already have opposite signs, so I'm going to get -20 on top and +20 on the bottom. So multiplying my top equation times 5. -20x plus 35y is going to equal 20. Then multiplying my bottom equation times 4. 20x minus 24y equals -20. So when I add those equations together, I get
5y.
35 minus 24 would be 11y. 11y equals 0. And when you take 0 and divide it by 11, guess what? You still get 0, right? So y is going to be 0. Do you want to substitute that in the top equation or the bottom equation? Top equation. If I put it in the top equation, what am I going to have? I'm going to have -4x plus 7 times 0 equals 4. Then I got to solve that. So 7 times 0 is 0, so -4x equals 4. And then I divide. And Kenyon said, oh, yep, it's -1. So x is -1 and y is 0. The next ones basically are reading your graphs with systems of equations that have 2 equations on there so that you can compare things. It says Pablo will rent a car for a day. The rental company offers 2 pricing options, option A and option B. For each pricing option, the cost in dollars depends on the miles driven as shown. So if I look at option A, which on mine looks like it's red, but starts here, my starting price is $30, and I can see that it increases the more I drive. Option B always is $60, doesn't matter how much I drive, I'm just going to pay $60. So it says if Pablo drives the rental car, yes, that was supposed to have a number in there. I think it was 75. We're going to make it 75. Gosh darn. Oop. So, if Pablo drives a rental car 75 miles, which option costs me more? So I have to first of all figure out where 75 miles is. It's not specifically marked, but hopefully I can figure out that 75 is halfway between 60 and 90. So if I look at that one, which one is going to cost me more? Option A or option B?
Option B.
Option B is going to cost me more because the option B line is above the option A line. However, then it wants to know how much more does it cost. So I have to figure out at 75 miles, option A is going to cost me $45. Option B costs me $60. So how much more does it cost? $15, right? 60 minus 45, going to give me 15 bucks more. Second part of this one, if I get rid of all my scribbling. For what number of miles do the two options cost the same? Well, they cost the same where they intersect here. How many miles is that? Well, the miles driven is down at the bottom, so if you go straight down from that point, you get 150 miles. Then it says if Pablo drives less than this amount, meaning less than the 150, so pick anything less than 150. Maybe you just want to do 60. Which one costs me less at 60 miles?
Option A.
Option A is going to cost me less, right? Option A. Number 11, it says Sam can choose plan A or plan B for his long distance charges. For each plan, the cost in dollar depends on the minutes used per month. So if I look at plan A, it's starting at $0. If I don't talk on the phone, I don't have to pay any money, and increases. Option B starts at $10 and is consistent from 0 to 80 minutes. I only have to pay $10, but after that 80 minutes, then it starts going up. So it says if Sam make up a number, because evidently all my numbers didn't go in there when I probably copied and pasted, how many minutes? Let's use 200. That looks like a good number to use. We'll get some numbers in there yet. 200. If Sam makes 200 minutes of long distance calls for the month, which plan is going to cost me less for 200 minutes?
Plan B.
Plan B. Right here at 200 minutes, I'm going to run into plan B first. It wants to know then how much less is it going to cost. So if I look, plan B is going to cost me $16. Plan A is going to cost me $20. So how much less does it cost? $4. 20 minus 16. Then it says on part B, for what number of long distance minutes do the two plans cost the same?
120.
120. That's where they intersect right above the 120 minutes. If the time spent on long distance calls is less than this amount, less than the 120, maybe you're going to pick 80, which one costs me less at 80 minutes? Plan A. Tammy is going to rent a car for a day. The rental company offers two pricing options, option A and option B. For each pricing option, it cost in dollars depends on miles driven as shown below. Hey, look at this one has a number in it. If Tammy drives the rental car 120 miles, which one costs me more? So looking at your graph at 120 miles, which one's going to cost more?
Option A.
Option A is going to cost me more. There's 120. So how much more is it going to cost?
$10.
$10. Really? Looks like it's more than $10 to me. $15, right? This one here is going to cost $50, And this one goes up to 55, 60, 65, looks like where it is across from. So 65 minus 50 would be $15 more. And I did find that when I was doing these on the pie chart that sometimes it was kind of hard to read. So either you need to make your screen bigger or print it out. Sometimes it's easier if you print the page because sometimes it is kind of hard to read on the screen to see exactly where you're at. Part B, for what number of miles do the two options cost the same?
60.
60 is where they intersect right there. And if Tammy drives less than this amount, maybe you pick 30s less than 60, which one costs me less? A. So a matter of reading the graph, and the hardest part is the second part of A, trying to find the difference because, like I said, sometimes it's kind of hard to read and see exactly straight, but if you print it, maybe use your ruler so that you're going straight, it should make it a little easier. Then getting into some word problems. We are going to do systems of equations, so we're going to have two equations and two variables. These first ones are all going to have one of our equations being a sum in there. It says the sum of two numbers is 42. Sum means we're going to, what's sum mean?
Both of them together.
Add them together, right? So, the large one plus the small one is 42. Then we're going to translate that second sentence. It says the larger number is, L is going to equal something. The larger number is 2 times as large as the smaller number. How would I show 2 times the smaller number? 2 times S, 2 S's. So what we're going to be able to do is solve this one by substitution because we know L is equal to 2S. We can get rid of the L and replace it with 2 S's. So now our equation says 2S plus S equals 42. And if we want to solve that equation, what should we do next? Put the S's together, right? Combine our like terms. 2S plus S is 3 S's. 2 plus 1 is 3. Then it should be fairly easy to solve. All we have to do is divide, right? 42 divided by 3. $14. So my small number is 14. I still need to know what my large number is. I knew my large one was 2 times my small one. So 2 times 14 would give me 28. And then I double check. Is the sum of my two numbers 42? Sure enough, if I add 28 plus 14, it is 42. Number 14 then starts off with the sum of my two numbers is 61. What would I write for my equation?
L plus S equals 61.
L plus S equals 61. The second sentence, the larger number is 7 more than the smaller number. So how do I write the larger number is 7 more than the smaller number?
L equals something else?
L equals, now 7S would be 7 times S, right?
So that's
We want to do more, so we're going to add, right? So they're going to write S plus 7, but if you do 7 plus S, it's the same thing because you have the commutative property. However, be careful on the subtraction. 7 less than something, the minus 7 has to go on the end, not 7 minus S, but S minus 7. So it's best to practice putting it on the end. So again, we can solve by substitution. We are going to replace the L with our S plus 7. So we have S plus 7 plus the S that was there equals 61. So combining our like terms, we would get
2s plus 7.
2s plus 7 equals 61. Then we would
Subtract the 7.
subtract our 7 and we would have 2s equals
64. Wait,
54?
Wait, no, okay, 54. I mean.
54, we subtracted 7. And so then we're going to divide by 2. So s equals 27. So my small number is 27. What is my large number going to be?
34.
34. How'd you get that?
27 plus 7.
27 plus 7, right? 7 more than my small one. And if I double check that, 34 plus 27 does add up to 61, so that would make sense. And the last one on this page is just going to be slightly different than those previous two. It says the sum of two numbers is 46 and the difference is 12. So if I do the sum of my two numbers, I'm going to have
L plus s equals 6, so 46.
L plus S equals 46. If the difference is 12, what would my equation be?
L minus s equals
L minus S equals 12, exactly. Notice I line those ones up straight up and down above each other because I already have opposites in front of my S's. And since I have opposites, instead of rearranging and solving by substitution, which I could do, I could just solve by the addition method. If I add these two equations together, L plus L is 2L. S minus S is going to cancel the S's out of there. And 46 plus 12 would be 58. Now all I have to do is divide by 2, right? 58 divided by 2 would give me 29. So my large number is 29. I still have to find my small number. I'm going to do that by substituting into one of my two equations. Which one looks easier to do?
The bottom.
The bottom? I picked the top, but we'll do the bottom. 29 minus S equals 12 then. If I'm going to solve that, I would do what?
Subtract 20.
Subtract by 29. So negative S is going to equal
Negative 17.
negative 17. And then I have to
Divide by
divide by negative 1. So S equals positive 17. 29 plus 17 is 46, and 29 minus 17 is 12, right? If you had picked the top one here and put your 29 in here, all you would have had to do is subtract the 29, and then you only have one step to do instead of two, but it works. All right, so check out that, what color was that section? Green? Nope, it was light blue. Check out the light